Okay, here we are, problem 27, page 502. This is in homework set 36. You have problem 29 as a sister. And this is, these two problems are using the product to sum and the sum to product formulas. And you've got an identity to establish here. This left-hand side has to be equal to the right-hand side. So we're going to modify the left-hand side and try to turn it into the right-hand side. And you're going to actually see that it's going to unfold pretty quickly. But if you're like me, you don't use product to sum formulas or sum to product formulas much. You know, I'm aware of some specific applications, particularly of the sum to product formulas, but they're way out at the end of this sum and difference to double half angle to these two sets of identities. They're too far out on a limb for me to kind of really keep track of them and keep up with them. So, you know, I'm like you here. I just have to reason this out as best I can. And I can't tell you by looking at it right now whether I should use the product to sum formulas or the sum to product formulas. I guess I'm leaning one way, and we'll see if it works out. I'm leaning towards the sum to product formulas because I've got sums here, in some sense products here. This is a single ratio, sine 3 theta, cosine 3 theta. This is a ratio with sums in the top and the bottom. So I'm feeling like the product and sum will turn, for the sine, will turn this into a product. And the product and to the sum to product for the cosine will turn this sum into a product as well too. And hopefully things will cancel. So, you know, if this works, this won't be difficult. So I'm looking at the sum to product formula, and let me kind of write them down. Sum to product. This is definitely a case of looking on a cheat sheet rather than trying to derive these things. The two formulas that I'm looking to are the sine alpha plus the sine of beta, because I got a sine alpha and a sine beta right there, and they're equal to 2 sine alpha plus beta all over 2 times the cosine of alpha minus beta all over 2. Yeah? Is that right? Yes, it is. And then the second one is the cosine of alpha plus the cosine of beta, because I've got a cosine alpha, cosine beta there. And it's equal to 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. Oh, look at that. I've got this common term in both cases. So if I form the ratio right here, I'm going to do that. In fact, if I form this ratio, then this left-hand side, by choosing alpha is equal to 4 theta and beta equals to 2 theta, the left-hand side becomes this. The right-hand side, you get this cancellation right here, you get this cancellation, and you get a sine and cosine. And just looking downstream now, you let alpha be equal to 4 theta, beta equal to 2 theta, alpha plus beta is 6 theta over 2 is 3 theta. So let me just stop talking, just do it here. I'm going to let alpha be equal to 4 theta, beta be equal to 2 theta. I'm going to insert that here. Alpha, sine of alpha then is sine of 4 theta, plus the sine of beta is the sine of 2 theta, all over the cosine of alpha is the cosine of 4 theta, plus the cosine of beta is the cosine of 2 theta. Oh, by the way, that's the left-hand side up here. And what's left? Well, it's the sine of alpha plus beta over 2. 4 theta plus 2 theta is 6 theta divided by 2 is 3 theta. The bottom is cosine of 3 theta, and that is the tangent of 3 theta. I'm going to write a big QED because maybe I should have written phew, because I really didn't see how to do that as we started, and it turned out to be fairly simple.